Hello student, good morning. Today we learn electric potential surfaces and relation between electric field and electric potential. Now first we start with relation between electric field and potential. Okay, for this student, in this diagram, a point charge plus Q is kept at point O and 2 points N, M and are placed at a distance from charge Q, x distance and x plus x plus dx distance on the x-axis. Now, the force acting on the test charge at point M is electrostatic force, and that force is a repulsive force also. Now we derive the relation between the electric field and potential. Consider a plus Q charge is kept at O and 2 points N and M are at a distance x and x plus dx placed lies on x-axis. Okay, therefore force acting on test charge Q naught at M is F is equal to Q naught Q naught E. Therefore, this force is a repulsive force therefore work done to moving it from M to N is dW is equal to F into dx, because student, the direction of force is in the direction of electric field, that is force in direction of positive x direction, and the charge is moving from M to N, so it is taken as negative, that is minus F dx, and the value of F is minus Q naught E dx. Now student, this Q naught is transferred to the denominator of dW Therefore, dW is equal to dW upon Q naught equal to minus E dx. Here student, you all know dW upon W upon Q naught is equal to potential, that is del V. Therefore, dV equal to minus E dx. Here student, this relation dV upon dx equal to minus E. Or we can also written this equation as E is equal to minus dV upon dx. This is known as electric field gradient or electric potential gradient. This is called electric potential gradient. Gradient. Here student, negative sign, negative sign indicates that the value of electric field is decreases with increase in potential. Okay, and student, here also x is distance, so electric field is 1 upon r. We can say this, that is, on increasing distance electric field will decrease, but there is a negative sign in the potential because of that कि अगर इलेक्ट्रिक फील्ड लाइंस मूव कर रही हैं पॉजिटिव x डायरेक्शन टू नेगेटिव एंड द चार्ज इज मूविंग फ्रॉम towards the positive charge, so the potential will increase as decrease in electric field. Copy this. This is called electric potential gradient or gradient of electric field. Copy all these. Okay, student. Now equipotential surfaces. Okay. Any surface is said to be equipotential any surface over which value of electric potential is same everywhere is called an equipotential surface. An equipotential surface. An equipotential surface may be a surface of a body or surface in the space. Okay. Now we take a equipotential surface and understood about it. Consider an equipotential surface of charge plus q having 2 points A and B apart a distance okay. Suppose this is an equipotential surface and the 2 points A and B in it with potential V and V. As definition, any surface over which the value of electric potential is same everywhere is called an equipotential surface. So in this surface, whatever is the point we take, the value of potential is exactly same. Therefore work done to moving a charge q from point A to B. Work done to moving a charge from A to B is W is equal to QV as per potential definition. Q dV. Okay, student. Now, this dV is potential difference of point A and B. That is VA minus VB. But we have VA equal to VB equal to V. Therefore, work done is equal to Q V minus V is 0. That is work done to moving a charge in equipotential surface is 0. Therefore, work done in moving charge one point to another 1 point to another is 0. In equipotential surface. Okay, student. Now we also have potential gradient, that is potential gradient dV is equal to E dx. Okay, student. Now we take this as negative E dx. Now potential is a scalar quantity, electric field is a vector quantity, and distance moving against the force is also a vector quantity. So when we take this as dot product, E dx cos theta. Okay, now dV, for equipotential surface the potential difference is always 0 because dV is equal to 0. Therefore we get E ds cos theta is equal to 0. Okay student, now these all value comes to the denominator of 0, we get cos theta is equal to 0. That is, the value of 0 in cos theta is on cos 90. Therefore, theta is equal to 90 degree. Here, this expression gives us the electric field is perpendicular or at 90 degree over the equipotential surfaces. That is, electric field is perpendicular on electric field is perpendicular on equipotential surface. Okay student, so copy this note now. After this, we take some examples of equipotential surfaces and their figures. Okay, now we take some examples for how to represent the equipotential surfaces for different kind of charges. First is equipotential surface for equipotential surface for an isolated charge is the surface of a concentric sphere spheres with charge at the center of sphere, at the center of sphere. Okay, these are represented as, suppose we have this sphere of radius r and this is its center and the charge is placed at its center. Therefore, the equipotential surfaces for this isolate charge at O is represented as the concentric sphere like this. And student, आपको पता है कि distances of sphere from its center are same, that is potential at r or for the surface first, second potential at a distance r1 for surface 2, potential at a distance r2 for surface 3, and similarly potential at surface s3 at distance r3 is this. Okay, now we have the potential surface for first surface is V, for second surface is V2, for third surface is V3. First ये V1 है, this is V2, one potential at this S1, okay, V1, this is V2, this is V3, okay. These are the potentials. So, according to the rule, potential is inversely proportional to the distance. That is, as distance increase, potential decrease. I am showing you with the increases value, decreases value. This is because R3 is greater than R2, then R1, then R. तो जो डिस्टेंस जितनी कम होगी उसका पोटेंशियल उतना ही ज्यादा होगा. These are the equipotential surfaces. From this, now we take the second kind of surface. Equipotential surface for a plane. for a plane is an parallel planes is an parallel same potential surfaces equipotential surface for a plane are an parallel planes surfaces with perpendicular to with electric field line of forces. Electric field lines of force. These surfaces are represented as these are the plane surfaces which are perpendicular to electric field lines. Okay. Copy this. Then we take other two forms of equipotential surface. These are the other two surfaces. First is due to dipole electric potential surfaces like this. These are the some special complicated form of the electric potential surface. And second, this is due to the positive identical charges. The equipotential surfaces is like this. Just copy. Then we go for the properties of equipotential surfaces. Okay student, this is last topic of today's lecture, properties of equipotential surfaces. As we learned earlier at the starting or definition of the equipotential surface, no work is done in moving a charge from one point to another on an equipotential surface, because the potential at every point in the equipotential surface is exactly same. So work done, which is given by W is equal to Q V. V is same, so V is equal to 0. So work done is also 0. Second, electric field is perpendicular at every point on such surfaces, because we have electric field is equal to Q E dV equal to E dr. On solving we get E dr cos theta. Okay, because electric field is perpendicular on the surface, that is theta, that is potential at the surface, it is potential difference, so this will become 0. Therefore cos theta is equal to cos 90 degree, so theta is 90 degree. This is a small proof the electric field is perpendicular on the equipotential surfaces. Next, no two equipotential surfaces can never intersect each other. If they do so, okay स्टूडेंट, अगर दो इक्विपोटेंशियल सरफेस जो कि इलेक्ट्रिक फील्ड को कैरी करती हैं और इलेक्ट्रिक फील्ड को रिप्रेजेंट करती है परपेंडिकुलर टू ऑन देम, therefore if they intersect, so at the same point there is two directions of electric field, which is not possible, so they can not intersect. Next and very important point is the surfaces are crowded in the region of the strong electric field, and strong electric field and are far apart, दूर दूर होती हैं in the weak electric field. It is given by the rule of potential gradient or gradient of electric field, that is E is equal to minus dV upon dr. Here we find the electric field is depends as on distance. Distance will increase, electric field decrease. Now with this sign we understood. Now student, the electric field is negative value of potential gradient, that is if potential will increases, the electric field will decreases with the electric field lines of forces. Okay, and if the potential will decrease, the value of electric field will increase as of this negative sign. Thank you. Copy these.